Okay, so first off, thank you to Barry and Dom for organising this. It's taken a fair amount of work to put this on, and I really do appreciate the chance to be able to, talk to you all about GraalVM. So thank you to the both of them for their hard work. The next thing is I'm not a great public speaker, so please bear with me. I've put together some slides today. So a bit about myself. I work for Oracle, and my responsibility is working with companies and developers to explain and raise awareness about GraalVM. And I also work with companies who want to take this into production, and I help them by working on proof of concepts, ironing out issues, helping them identify how they might use it in production. So that's a bit of a background on me. Bit further, I mean, only recently Oracle, I've self-employed for a very long time doing middleware stuff, content management and Java. So all in all, I've done a bit of everything in my life, jack of all trades, basically, master of none. So if I share my screen, if you could all just let me know that you can hear me and you can see my screen. I also like to say the backdrop is what Swindon looks like at the moment, where I'm based. Very tropical. So if I get my slide deck up. So, as I said, I'm going to talk to you today about GraalVM, but what I do want to raise at the start of this is there are two versions. There's an enterprise version with paid support, better performance characteristics, and there's a community version, which has most of the functionalities, almost functionally the same. And during this presentation, I am going to sort of flag up some of the differences and talk about some of the benefits of the enterprise version, but in no way is this, trying to shove GraalVM Enterprise Edition down anybody's throats. There's a free version, feel free to use it, but also be aware of what the paid enterprise version offers. And if that makes sense for you, then fine, get in touch. So the talk today, GraalVM. I'm Kris Foster. I have to put a safe harbor statement at the start of all of my slides, and this is basically to say that anything that I talk about in relation to the future of the product can't be relied upon for purchasing decisions. Things may change, etc. The other important point I need to talk about is the GraalVM native image technology, and we'll talk about what that is during the talk. But this is early adopter. It's production ready, but it has early adopter status. And that basically means that if you're using it, in order to get support, you might need to, Oracle might ask you to upgrade to a more recent version in order to have the support. When it goes into, when it goes out of early adopter into full supported version, that won't be the case. There'll be long-term support versions, but right now it's early adopter. So what is GraalVM? I guess a lot of people have heard about it. It went into, there's only been a product released for the last year, but its roots go much further back to almost 7 or 8 years, and it's come out of some academic work and out of Oracle labs based in Zurich. And it really is comprised of three things. I like to think of these three pillars. To a lot of people it seems quite complicated, it does a lot of things, but if we think about these three pillars, that can help us get straight in our minds what it is. So the first thing is it's a new JIT compiler. So inside your JVM, I'm sure you all know this, there's a JIT compiler, and that's what makes your code performant. When you're running code, the runtime, your JVM is watching it, identifying things that need to be made more efficient, basically, and they're passed to the JIT compiler, and the JIT compiler generates native code, which makes these little hot sections of the code faster. So we have a new JIT compiler. The second pillar is the PolyGlot Runtime. So polyglot just means many languages, and basically it means that we now have a direct way to run languages, many languages on top of the same Java runtime. I mean, previously people have written JRuby, Jython, various other languages that compile into JVM bytecode, and those all run. But this new PolyGlot runtime basically takes away some of those details and adds new efficiencies. So we can run languages like, we can write an implementation for Python, JavaScript, Node, Ruby, etc. These are all implementations that we have, and they can all talk with very low overhead to each other on the runtime. And we will look at some examples of this and go into a little bit of detail about what this means. The third pillar, remember it's all about number 3, is the cloud native or the microservices story. This is native image, the ahead of time compilation functionality. So basically you can take a JVM language and the JVM, and you can take your application and you can compile it into a native executable. So your JVM plus your code, from that we can generate a single native executable file. Why would you want to do that? Well, for a number of reasons. It starts faster, it uses less memory, it's got a smaller package size. So there are a number of benefits, but we'll look at that. And that fits very well with the idea of microservices, where we have lots and lots and lots of individual Java applications, and we want to try and make them as efficient as possible, and also for function as a service. So I like to think of Data Soul 3, that's a magic number. So if we think about these 3 pillars, that really helps, certainly in my mind, to get straight what GraalVM is. It's the JIT compiler, the new JIT compiler, the polyglot functionality, and the native image functionality. It's based on a lot of research. You can go online and see the papers that relate to this. So if you go to graalvm.org/publications, you can look at the papers that are published, that relate to the JIT compiler, the polyglot functionality, native image. There's a lot of this has been released as papers that are available publicly. And a quick overview of the differences between these 2 editions. So I said that there's 2 editions. You choose the right one for you. There's a community open source edition and an enterprise edition. They're basically almost functionally the same. And really it boils down to, getting support and better performance in some cases on the enterprise edition. So if we go through this table, in the GraalVM community edition, all the source code is open sourced, and in the enterprise edition, a lot of the source code is shared with the community edition, but some sections are closed, proprietary basically, and that relates to some performance improvements in the JIT compiler and some of the features in native image. The community edition, is it supported? No, but there's an active community and frequent releases, so the code is constantly being updated, and issues can be raised and they're fixed. In the enterprise edition, you get a proper support license. It's licensed under the OTN license, which means you're free to evaluate and develop on it. But when you come to production and you want support, that's when you need a license. And then finally, features, the polyglot functionality, the JIT and the native image are all available in the community edition. So you can use the new JIT compiler. It just doesn't have as many of the optimization steps as the enterprise version. You can use all of the polyglot functionality in the community edition. The native image as well is available in the community edition. There are some differences. In the polyglot version, the object model that underlies everything is slightly more performant, and we have managed execution for C and C++, which I'll talk a little bit about later. There's more optimization phases and stages, etc., in the JIT compiler in the enterprise edition, and there's a number of features for native image that basically make it more production ready at the moment. And the commitment to open source, well, a lot of the GraalVM source code was obviously developed inside Oracle Labs, along with contributors in the communities, such as Red Hat, etc. So there's about 3.6 million lines of code that have been released, and that's all available online. You can go to GitHub and download the repository and look through the code and find out what's there. And here we have a kind of a breakdown of where the different areas of the code are, so how much is in the Python implementation versus the core and the compiler and the truffle implementation, etc. But basically there's an awful lot of code that's been open source to the community and is under active development. We recently started a GraalVM project advisory board, and basically this is just to oversee the community edition, to help with engagement and to get the sort out any potential issues with contributors, committing changes and making sure that it's an actively developed and healthy ecosystem. It meets every 3 months. Once a year they meet in person, but I think that might be off this year. And we've got people who are on the board from a lot of different companies, Red Hat, Amazon, Microdoc, all kinds of companies, Object Computing, who make Micronaut, many, many different people. I've talked about the benefits of the Enterprise Edition. I won't go on about that. So how do you get started with GraalVM? Well, you can easily download it. Basically, the core is packed as an archive. You explode that, and if you're running Linux or Macs, you then just need to put GraalVM home on your path. You can also optionally make Java home the same thing. It's a completely compliant JVM runtime. So if you can run a Java application on your JVM, you can run it on the GraalVM, and it's very similar to setup, basically. You then just need to put it on your path, and then you can run your application. Check out the docs. The docs on the GraalVM org site are really, really good. There's lots of tutorials and lots of detail on how the individual elements work. But as I said, you'll find lots of code examples, works examples that really help you to understand what's going on. So very good set of resources. So going back to the idea of these 3 pillars or contexts, what is GraalVM in the Java context? So you have Java, it's a high performance runtime, and inside your JVM, which is at the bottom, you have a JIT compiler, and that's what makes your application fast. In GraalVM, we replace the JIT compiler with a new JIT compiler. With the Community Edition, it's hard to say exactly what the performance characteristics are, because that's not perhaps like it's not the main thrust in as much as it is with the Enterprise Edition. But basically, you have a new JIT compiler, and this has a number of benefits. The JIT compiler was written in Java, and it was designed from the ground up. And you would think that that might cause some problems, and it did in the early version, in that the compiler itself needs to be interpreted and then compiled. But we have used the native image functionality to make a native executable of the Java JIT compiler. So now you have the performance characteristics of something like the compilers like C1 and C2, which were written in C++ and obviously compiled to native code. So this gives you a number of benefits. That the JIT compiler, this is now the default, basically, libgraal. So when the JIT compiler kicks in, it starts faster and it runs faster, basically, because it's native code straight away. But also, you don't have any pollution of the heap. So if you're profiling your application, you won't see anything related to JIT compilation appearing in the heap, because it operates in its own separate part of the memory space. So it doesn't pollute anything to do with your application. Again, it's built on top of the Oracle Hotspot VM. So if you think about it in the Java context, it's familiar, right? It's familiar, well-tried technology. We have just changed one part of it. And how did we achieve that? Well, a new API was added to the Hotspot VM, which is the JVM CI, the Java Virtual Machine Compiler interface, that allows you to plug in new implementations of the JIT compiler. So by adding this interface, we're able to swap in different JIT compilers, and this I think has been available in OpenJDK since version 9. So, and you can use it on, say OpenJDK 11. You can use the experimental options to switch to the GraalVM, or you can just download the GraalVM runtime. To go over a bit about what I was saying earlier, I'm sure all of you know this, but basically your source code gets compiled by your Java compiler and you generate bytecode. That's loaded by the runtime. And initially it's interpreted, the hotspots are identified, and those hot methods are passed to the compiler, C2 in the case of hotspot. And that's what makes it fast, right? So those things that the compiler is spending a lot of time in are turned into fast native code based on evidence, not our guesses, evidence gathered by the runtime that tells us this method definitely is very hot, it's been called a lot of times, we need to make it more efficient. Well, with Graal, as I said, we now have just swapped in a different compiler that runs faster. And then as well as that, the Enterprise Edition runs faster. And as well as that, we have some other features, which is the polyglot functionality, and we'll come to that in a minute. In terms of compatibility, GraalVM is compatible with JDK 8 and 11. It's based on the Oracle JDK. Obviously, it goes through lots and lots of tests, passes all of the JVM compliance tests, so you can be guaranteed that it is a compliant Java in the same way that any other JVM runtime is. And it's now also certified on top of WebLogic. So if you use WebLogic and you want to use GraalVM, that's now a possibility because you won't invalidate your WebLogic server your support. So there are these two options now when we think about it in terms of the Java scope as well. You have all of your JVM languages, Java, Scala, Groovy, Kotlin. They can be run in the JIT mode. They will work in exactly the same way. And you can kind of just think about swapping one JVM for the other. And then we also have the ahead of time compilation functionality, where we take the application and the runtime and any libraries, and we generate a native executable from it, which is a single file that can be distributed and run on your Linux platform, your Mac platform, whatever. We have some performance statistics for the Enterprise Edition that are based around a new benchmark called Renaissance. The idea of this benchmark is that rather than just taking kind of computer sciencey type tasks or maybe sort of simpler tasks, we try to incorporate more complex Java business related kind of activities. So there are Apache Spark benchmarks in there. There's Finagle, which is from Twitter, and there's various Scala things as well we look at. These figures here are all relative to OpenJDK, and the black line indicates performance that's exactly the same as OpenJDK. For the Enterprise Edition, we should always have performance that is better than the matching Oracle Hotspot VM. So we should always expect that the performance is better. For the Community Edition, we would always hope and expect that the performance is better, but there are no guarantees. In certain cases, the performance may be the same or a little bit worse. But with the Enterprise Edition, if we find that there's a performance regression for a particular benchmark, that's treated as a high priority bug, and we then aim to get a patch out for that, which will improve the performance. And this graph, shows you a number of different things, but you can see in some cases, obviously there's silly numbers like three times faster. That's not necessarily going to be representative, but we feel that on average, you ought to be able to get somewhere between 10 and 30% performance boosts for your apps if you're using the Enterprise Edition. It will vary on what your application does and how it's been written. If you've got an application that's been kind of hand optimized, it's written very much with a focus on making everything very optimized and performant, it's going to be difficult for the JIT compiler to possibly make any improvements on that, so you may not see any benefits. If your and this applies to the community edition as well. If your application is waiting on, I/O, then you're not going to see much in the way of performance improvements. So it's really suited to things that are doing a lot of processing that are CPU bound. And Twitter use it now. So every time you use a every time you use the tweet service, you read a tweet, you send a tweet, whatever. Basically, all of their Scala microservices are running top of the GraalVM Community Edition, and they've done that because they get better performance through doing it. And we've started using it internally now on our cloud infrastructure. The telemetry service is now switched over to using GraalVM, and we are switching more and more services over to make use of it. And the reason we're doing that is for performance, but also I think for me the figure that stands out there the most is that there were 0 issues. So if you can imagine like how many cores are running in the telemetry service for OCI, there's a lot. So 30 million plus core hours and not a single issue raised. So it is production ready. So I wanted to do a couple of little demos just to show you basically how it works. And the first of these is a JIT demo. So we're going to look at some code, some kind of modern, very sort of abstract code, and I'm going to run it with GraalVM, and then I'm also going to run it with by switching off the new JIT compiler. And what does this code do? Well, I'm using the JMH package, the Java microbenchmark harness, to basically take an array of integers, map over them, do some things to them, add numbers, times them, that kind of thing, and then reduce that array into a single number through summation. So this is using the arrays and streams API. So quite abstract, very sort of functional in the way that it looks. We're using map and reduce, etc. And to be honest, maybe it's the kind of code that a lot of us would like to write, but sometimes are a bit concerned about writing because we're worried that it won't be performant. So if I the bad thing about using Zoom is the bar at the top keeps appearing over the top of my shell, so I can't see what I'm doing. That's better. So I've got a little script here that that runs this. I'll quickly show you the contents of that. It's nothing amazing, basically. We have here just call in the GraalVM Java version with the jar for that source code, and then we're going to call it again, but this time we're going to pass in a flag that switches off the new JIT compiler, so we can compare and contrast, right? So the first run is with the new JIT compiler, the Graal JIT compiler, and the second run is without it. So if I run this, kind of feel like I should have a potter's wheel. But basically, you can see that it's running. It has a one warm-up iteration, then I think it does 3 further runs. And what it's going to look at is the average time for completion for that benchmark method. So we're seeing figures of around 11 nanoseconds, yeah, at the moment. And this is the GraalVM JIT compiler. Iteration 2. Almost done. So the figures we get back are on this line here. This is like the summary. It ran 3 benchmarks, and it came out around 10 nanoseconds for the operation. We're running it now without the Graal JIT compiler, and already we can see, potentially some much bigger numbers. We'll let that finish. Again, this is a bit of a toy example. I don't want to kind of make too much out of it, but it demonstrates in a very simple case, where the strengths of Graal are. Okay, so, that came out as a factor bigger, right? So 200 nanoseconds there. Maybe it could be 100, but it's almost a factor of 10 bigger. So it's slower. So the GraalVM compiler really sort of shines at these kinds of abstract modern Java. And you can maybe think about using it as a way to write the code you want without having to perhaps worry about the performance, because you could be fairly confident that the JIT compiler will make that code fast for you. And the second demo I was going to show you is very, very similar. So I have a large text file, 144 megs, and basically this is a lorem ipsum, repeated ad infinitum, without wishing to sound a bit lorem ipsum-y myself. So it's a file we create that contains lorem ipsum repeated many, many times and kind of mucked about with. What we're going to run is a Java application that's going to count the unique incidences of words within it. Again, using the array in streams, what does it do? We can pass in, a number of files. We're going to flat map those files with this method down here that reads them in as lines. And we have to flatten it because obviously there could be more than one. And then the lines are getting broken into words, so we flatten that as well whilst we're mapping this. And then now we've just got this huge stream of words from inside that file. God knows how many there are in that huge file, but a lot, I imagine. We get rid of any non-character characters, numbers, dots, whatever. We get rid of any words that happen to be zero because of some kind of strangeness in how we split things or character replacements. We lowercase to normalize everything, and then we collect everything. So based on applying the identity function, we're going to group things and then count them, basically. So we're going to be counting the instances of each individual word and then sorting that set that we get back and just getting the top 10 and printing them out. So kind of very sort of functional, and to my mind, very functional and abstract. It's a good sort of description of what we're doing that doesn't focus too much on, looping, etc. So if we have a look at how this performs, we've looked at the size of the file, that's quite big. If we look at how this performs, I'm going to run it. This time I'm running it with the Graal JVM. I know it's a little bit like watching paint dry, but apologies for that. It's very hard to make this interesting, this particular part. The other parts definitely are. So we can see that, that's run about 16 seconds in total. I mean, it will vary, obviously, with the load on your machine. And there's always the slight chance that this is going to go wrong and the Graal version was going to run for longer, in which case I'll repeat. So this time I'm going to do the same trick we did last time. I'm going to run the application, but I'm going to switch off the Graal compiler with the -xx -use JVMC compiler flag. When that ran earlier, actually, before this, it was before the session started, I was just testing things out. The first one ran for about 10 seconds, and this, with the Graal compiler switched off, it ran for about 15 seconds. It's obviously running a bit slower now, so in and around 20. So there's a noticeable difference there. I would not quite 2/3. If it was 15, 20, what would that be? 5s, 3/4, right? Okay. But it's a significant difference. So let me get back to my presentation. So we've looked at a couple of demos basically, and the big thing and the most obvious thing is that it's just as easy as like replacing one Java home for another. You download the runtime, and then you switch your JVM for the Graal JVM, and you can switch back, you can do what you like, you can have multiple versions installed. It is just a Java, is a compliant Java with some extra features. So any Java application you have, it should be able to run. If it doesn't, then I would suggest that's probably, a defect. And I think this will be available in the recording, and the slides will probably be available afterwards, but a couple of links for you. The GraalVM demos is a really interesting GitHub repo to go to. It's got a number of different demos that show you how to use native image, polyglot functionality, a couple of examples of how to look at the performance benefits of the JIT compiler, and also the blog post by Kris Foster, Top 10 Things for GraalVM. This again goes through a very sort of similar set of things, but it's really useful if you're getting started with GraalVM. It shows you some interesting use cases and ways of using Graal. So we've talked about the first pillar, which is the new JIT compiler, which you would expect to see more performance with, and we did in our demos, right? But your mileage may vary. The Enterprise Edition, as I said, the performance will always be better, otherwise it's bug. Community Edition, we would always hope for better performance, but sometimes maybe it isn't. So Polyglot. These days, people are building their applications out of different languages, the right tool for the right job, right? We might have a Java business logic, bit of Java business logic in an application, which is represented by this middle bit. We've got some Python, maybe some machine learning or data analysis, whatever things that Python's good at. And on another side, we might have a Ruby web front end or a Node.js front end. And all these applications are talking to each other, and they all come with their own runtime, right? Which needs to be patched. So you have your Python interpreter, your Ruby interpreter, and these maybe are all running in containers as well. What you can do with Graal is that these applications can all run on the same runtime. You could use the GraalVM runtime for Python, Ruby, JavaScript, R, Java. So that would mean that you've only got a single runtime to patch. So when you patch your runtime, you're patching it for all the languages. And that hopefully is helps reduce the sort of overhead of keeping applications safe and up to date. There is another benefit as well. So these applications not only would be using the same runtime, you could imagine them running in different pillars, but just using the same runtime. They could also run in the same program. So you could have a Java application that embeds some Python, uses some Python or some R for a particular task. Or you could have it the other way around. You might have a JavaScript application that embeds some Java. And I'm going to try and show you an example of this later on, assuming I don't get jinxed. But I'm going to show you a JavaScript application that makes a call to a Java library. And this gives us maybe a new way of thinking, or perhaps an old way of thinking about the application. We can use the right languages that we're interested in, Python, for instance, for specific tasks where they're good, or R, where it makes sense, without having to try and find a library for a language in which it's hard to find, or the functionality doesn't exist, or we've got developers with a certain set of skills, maybe they're knowledgeable in R, say data scientists. We can leverage those skills and they can be used inside of our existing applications. We've also got the ability to debug between the applications as well, but to cross the language runtimes for the hosted languages we have anyway. So from JavaScript to R to back to JavaScript, which is kind of an interesting piece of functionality. So yeah, you get the idea. Basically, you get to write code in the languages you want to write, using the libraries you want to write. I showed this earlier. So how do we do that? It's built, GraalVM is built on top of Hotspot, right? We just swapped in the JIT compiler. Well, I don't know if you remember one of the earlier slides, a little orange box popped up and said other stuff, other functionality. Well, some new things have been added to the GraalVM runtime, and that mainly is the Truffle framework, Truffle API. Truffle is the framework that lets us implement languages that will run on top of Graal, on top of the Graal runtime. it's a way of describing your languages and a common API, so that you have a common API for accessing the OS, threads, etc., and a common object model underneath. So if you write an implementation of a language A, say Ruby, and then you write an implementation of R, both of which we've got here, the objects and the types between them can be passed very, very efficiently. So you can use one language inside of another. And there are also some kind of clever performance tricks that can happen because they're all using the same runtime. Basically, you don't need to think about I've never written a language, but if I was going to write a language, you typically start out by probably writing an interpreter, thinking about what the semantics and the grammar, etc., and what your language is supposed to do. And then you hit a roadblock that you want to make it fast. So then you have to think about whether you're going to somehow compile it, or write some form of JIT for it, or target another runtime, language runtime. Well, with the Truffle API, I mean, you could just stop at writing the language, making it correct, basically. You can rely on Graal, the Graal runtime, to provide access to the operating system, etc., and also to make it fast, because the methods can be JITted. So at the moment, we've got, in terms of languages that sit on top of Truffle, we've got Ruby, R, WASM, JavaScript, and Python. And some of these are more complete than others, and I've got a slide in a second that shows you what the current state of play is. We've also got an LLVM bitcode front end, so you can load anything that's been generated by Clang as bitcode. So if you have some C++ code or some C code, it's entirely possible to run it on top of the GraalVM runtime, so on top of your Java runtime, basically. And there are reasons why you would want to do that, in terms of maybe you would want interop with other languages, or if you use the Enterprise Edition, we can do managed execution. We can make sure that when you write to memory, it's actually writing to the heap. We can do array band checking. We can do some clever stuff around checking your pointers, etc. So you could trade, obviously you would be trading some performance, but you would be trading that performance for safety. It's just another choice. So a completely frank and open description of where we are with the languages. So we've got 3 columns here. Production ready, that's ready to go. You can use that in production today, and that's completely fine. Experimental, that's working, good. There are a few rough edges. We can't yet say that it's, production ready. And visionary, some things work, some things don't. So production ready, any JVM language, Java, Scala, Groovy, Kotlin, they all work. If you can compile it into JVM bytecode, then it will work on top of Graal. JavaScript and Node.js, they work and are production ready. With Node, we test against 90,000 plus, I think, NPM repositories, and we have very high pass rate, basically. So almost any NPM repository that you can grab will work on top of GraalVM. Native image is production ready, so you can build native images now from your JVM languages, and they are production ready, considered supported. The only thing is that it's early access, so you might be asked to upgrade the version of native image that you're using. The visual VM, we bundle JVM with GraalVM so that you can basically load and inspect running Java processes, and that could be a GraalVM node process, for instance, see what's happening inside of the threads, generate heap dumps, etc., which gives you an insight into what's happening inside your runtimes. Ruby is the completeness for Ruby is pretty good. R is pretty good, as is the LLVM toolchain. Python, I think the language, we can say that the language Python 3 is implemented. Lots of things work, and we've got real focus on making sure that the data science stuff is production ready, NumPy, SciPy, etc. Some of the issues come around the interface to the bits in the libraries that make NumPy fast and the native code, and we're looking at how we can get that to run fast and safely. WebAssembly, GPU integration, again, those are more experimental. Some people are using them, etc., but you wouldn't consider them at the moment to be production ready. they're worth checking out. I mean, the CUDA repository on Graal on GitHub is really interesting, and the idea of that is to allow access inside of any of the polyglot languages like JavaScript, for instance, directly to the graphics card. So through the CUDA API, so that you can write kernels and do stuff on your graphics card. Again, I've talked about some of these tools already. We have like this unified debugging using Chrome tools for all of the hosted languages. You can jump from one language to the other. You can't at the moment jump between a JVM language and a hosted language, say JavaScript, debugging back and forth. That may change. I've talked about Visual VM. We also have these CPU sampler and profiler flags that you can pass into any of the hosted languages. Basically, when you run it with these flags, the CPU sampling will happen. So it will check every millisecond, say, I think it is. It will take samples of where in the code your runtime is at the moment, the application is, sorry. And from this information, you can see where the hotspots are, and you can use that to performance tune your application. So I think this is and I think you'll find this example up on the GraalVM.org website. It's a JavaScript application that calculates primes up to a certain number. And there's a tutorial that goes through looking at using this functionality to identify the hotspots and see if we can make it any faster. Again, that's pretty interesting functionality if you're trying to tune something. We have a language installer. Everything's done, installing languages is done through this GU tool, the GraalVM Updater. If you're using the community edition, basically you can just type GU install Python, Ruby, whatever, and it will download and install the language. If you're using the enterprise edition, you need to download, because of accepting license terms, etc. You need to download the language jars and then install them using some flags and a file path. But again, that's covered in the docs, but it's not that different really. Basically, we use this package tool to install and update the languages that are available on the JVM. And as on the GraalVM, as new languages become available, you'll be able to use GU to install them. So I talked a little bit about the possibilities of using, one language inside of another. So here I've got an example I've lifted from like an Express Node application that I wrote or copied basically off the internet. Don't think anyone writes any code anymore. This shows how easy for me it was to drag in a Java library, a Java type, and use the object within inside the JavaScript. So if you look at the first circled red box, basically using these new keywords, these new objects basically in JavaScript that are available because of the GraalVM runtime Java and PolyGlot, etc. We can load Java types that are available on the class path. So we can tell Node, we can augment Node with a class path and tell it about jars and classes to load, etc. And then they're available to be called inside your JavaScript. So I've loaded a class, and then on that class I call a method that returns an object. And then I can use that object, and the types on either side make sense. So, when I'm in the second box, when I'm calling this classify method, I pass in a path, a string, and that's a JavaScript string, but that gets converted into something the Java code knows, into a Java string. And then what gets returned from this classifier method is a string, and that's converted without any kind of boilerplate or ceremony into something that JavaScript understands. So it is quite simple to pull one language into another, and I think that makes a lot of sense to maybe not need to reinvent the wheel. You want to try new things. You've got existing libraries. It doesn't take much to refactor them a little bit to make them into kind of like proper libraries that you could say add some kind of factory method to, and then you can call them from inside your Node application or your Python, Ruby, whatever it is. So done 2 pillars so far. I'm starting to get my voice starting to go. The third pillar, and I won't keep you for too much longer, is like microservices and the cloud. So this is the native image tool, and I'm going to go into a bit more detail about this because I guess it's maybe a bit more complicated, a little bit more interesting. So a lot of applications these days are built out of lots of Java applications talking to each other, which you kind of can kind of see here. Each one has its own JVM. So they could be quite large in size, and they're all talking to each other, maybe over a message bus or REST or whatever anyway. Probably all in containers. But you've got the JVM and you've got your Java application on top. So it could be quite a large footprint in terms of package size. The startup times as well, you have like, you know, slower startup times because it's JVM application, Java application. It takes time to warm up and to get started. The JVM is doing a lot when it starts up. With the native image tool, you can shrink the applications basically down in size, so we can have less memory usage and faster startup times, and a single file. You can package them as a single file, which I think is really interesting. Basically, because once you have a single package file, you can use smaller containers. But also, if you think about it, if you have like that single file, and with the native image tool, you can statically link in all of the libraries that you want, the attack surface for that container becomes less. You know, there's less in there, less going on, so that your application in some way becomes safer. There's less ways that it could be hacked. So yet another graph, sorry, but this is about showing the startup time. So when we talk about using native image, we typically recommend that you go with a framework that supports native image out of the box. And three that stand out at the moment are Helidon from Oracle, Micronaut from Object, and Quarkus from Red Hat. All three of these are able to make native images. They make some assumptions, and they're built in such a way that making a native image is easier. There are still, you know, some constraints, and we'll perhaps touch on that in a minute. But for each of these applications, we've built a kind of a hello world basic RESTful application. And we've looked at the startup time when it's running kind of in Java mode, which is the green bar, and in native image mode. And you can see there's some really big differences. So like the Java app might be running in a second or so, but the native images, whether it's 30 or 11 milliseconds, in my mind, there's not really that much in it. They're all starting almost instantaneously. And if they start instantaneously, that probably means that maybe, you know, scaling, we can think about scaling more dynamically. Maybe we don't have to have as many instances of an application running to handle peaks, etc. of the load. It's possible maybe we could, excuse me, that we could scale, you know, based on demand. Again, that'll depend on your architecture and, you know, your application, etc. The same kind of graph here with memory footprint. It's the same three applications, the same application, I should say, really, done in three different frameworks, and we see big reductions in the memory footprint. And I'll try and explain why we see those startup time improvements and memory reductions. Excuse me. So yeah, predictable performance characteristics, etc., and rapid scaling up and down. And with the Enterprise Edition, we have a few extra performance things. This thing called PGO, which I'll talk a bit about, basically profile guided optimizations. We try to gather that optimization information that the JVM would be gathering to do its JIT compilation, you know, finding out based on what's happening to the app, what are the hot methods, etc. And we can pass that to a native image build so that it should make the native image build optimized for the workload. And we've also got a new garbage collector, G1 garbage collector in the Enterprise Edition of native image. So, you know, if you use a different framework, you'll see different figures, but the rough characteristics here are I think what stands out for me. With native image, you'll see a faster startup time it'll get to the peak performance like almost instantaneously, whereas the JVM will take time to warm up. Currently, the JVM will reach a higher throughput, so when it's warmed up, it will be, you know, handling, you know, more requests per second. But we're looking at ways to improve the performance of native image over time so that it approaches what you can achieve with the JIT compiler. But that kind of, I suppose this graph would kind of be useful in terms of understanding, you know, what are you doing? Would you want to use native image? Do you want to use a JIT compiler? You know, if your application is going to run for a long time, days to months, whatever, then the JIT compiler makes sense, because you only pay that penalty at the start one time. If your application is short-lived, you're stopping and starting them more frequently, that performance penalty is going to be paid many, many times. So it would make sense to go for probably a native image, because you're not paying that warm-up phase penalty, repeatedly. So kind of this high level inside the gory details of native image. Imagine it's like a sausage machine. On the left-hand side, we have all the things coming in. On the right-hand side, we've got the sausages coming out, the executables. We take your Java application, the libraries, the JDK, and the substrate VM, which is our trimmed down version of the JVM that lives inside native images. And that's the thing that basically manages memory and provides access to the OS threading, files, whatever. We go through a stage of static analysis where we try to figure out what's loaded by the application. We want to try and get rid of as much dead code as possible. So if you're only using parts of the JVM, then those are the only bits we want. And I think you can do something similar with JLink, right? You can shrink the size of your application, but native image takes it one step further, and its dead code analysis is even more aggressive. So we basically iteratively try and figure out, what's going into the application. And at the same time, we also do some heap initialization. We see what we can load into the heap during build time, basically, and snapshot the heap for saving. And we package that inside the executable that's released. So then the next step is the ahead of time compilation. So once we figured out what the minimal set of the application is, what we think is actually being used, we'll natively compile that along with the substrate VM. But we also have these snapshots of the heap that contain the state of the application when it starts, and we can use that to make the application start warmed up, basically. So when it starts, the snapshotted heap is loaded into memory directly, and the application starts warmed up. So the heap snapshotting and the starting as native machine code and the reduction of what's in the executable, those are the things that really lead to the startups times speed ups, as well as ditching some things that we don't need from the JVM because we're not doing anything dynamic. Or if there are dynamic things in the code, we say what's going to happen dynamically at the start and allow for that. So by making these assumptions, this enables us to get this really fast startup time, and also the reduction in memory, basically, because we're being very careful about what's in the application. Going into it in a little bit more detail, I mean, if you look at the central box, there's this, it's called the points to analysis. You tell the native image tool, and I can show you that maybe in a minute, how you run that. The native image tool, you tell it about the starting point of the application, and it looks at that class, it does some static initialization, does some static analysis of the code, and it tries to follow the links that it finds to classes. So it'll find, this class loads this, and this, and then from these ones, it then follows the tree down, basically trying to identify that is actually used. And we keep going round on this loop, this points to analysis, following, what's pointed to until we can go no further. And that's called the fixed point, and that's when we end. And the code that we've identified at that point is what gets statically compiled. I mentioned a little bit earlier that we also have the ability to link in libraries. So typically when you deploy your native image, there's a couple of things that need to be there. Say on Linux, you need like a C library and zlib, I think. You have the ability to tell native image that you want a statically linked object, so that no dependencies on anything, basically. And this is where, if we do that, this is where we can start to look at Docker Scratch containers to try and shrink our image. Well, I'm in two minds about whether it shrinks it, because basically you've got the library statically linked in, or you've got the library in the container, but you have that option, basically. So I mean, I guess it's kind of obvious from what we were looking at earlier that there's a kind of a closed world assumption. Native image has to know what's there. It has to know what it can find. So if your application didn't do anything dynamic, it didn't load any classes, it didn't have any reflection, etc., this closed world assumption, this points to analysis, would be more straightforward. It would follow links to things basically until it ran out of anything, and it would know everything about, you know, what was reachable in the application. But Java's more dynamic than that, and you would think that it would be very hard to take a Java application, because like reflection is used in lots and lots of different places, lots of libraries, all kinds of places. Dynamic class loading is used in lots of different ways, and you would think that a lot of applications you wouldn't be able to make a native image out of them. Well, you know, that was kind of sort of foreseen by the people building native image, and they have, in the tooling, they allow you to specify, you know, you can pass in configuration that captures this kind of information and passes it to the native image tool, so that the native image tool is informed about any of these instances, that, you know, there's reflection used here, bit of dynamic class loading there, etc. And it can allow for that. Basically, that becomes part of the information about classes that are referenced, and that could be done by hand, but we try to make that easier through the use of the native image tracing agent. So if you're using, what's a good way of describing this? So you would want to run your application. Imagine running your application, but with a spy installed in it, an agent that watches everything that's happening and records instances of reflection, dynamic class loading, etc., and captures that information to some config files. These config files that we could use later on. Well, that's what we do. You know, that there's, when you're about to build a native image, the first pass is really to build your Java application. Make sure that your Java application works, because that really is, you know, your functional unit, right? The Java application with the unit tests and integration tests, etc. That's the thing that you want. The native image is almost, you could think of it as an optimization step. Once you have your working program, you then want to analyze it. So I don't know if you can see roughly where my mouse is. I can't highlight it because I'm in presentation mode. But we tell Java to load the native image agent, and it will trace all of these kinds of things I've talked about. You have to pass in some, you know, parameters where you want it to write out this config to, basically. And we would typically suggest that you run it multiple times. Reason being that you might have different paths through the execution of the program based on different input data, and that might trigger you know, different parts of the application, basically a reflection in this part of the application that wasn't triggered by the data that you passed into the first call of the application. So if you've got quite extensive unit tests, that shouldn't be a problem, but basically you want to try and run it a number of times, perhaps with slightly different data, and that should capture all of the information you need to build to a native image. You would also probably want to look at the source code, right? Just eyeball it and make sure that nothing's been missed, look at the configuration. But that's the basic approach. You should use the tracing agent to get this configuration so that you can build your native image. Next thing, profile guided optimizations. I talked a little bit about this. It's an enterprise only feature, but basically you can profile either your Java application or your native image and capture this profiling information. And this allows you to get optimization benefits. You know, it could look at optimizations that could be done on the application based on, you know, how the application is running. And this could be passed into native image to put some optimizations in that work for this particular scenario. And you can see performance benefits with that. We have, it's not released yet, but we're working on a Kubernetes operator that lets you, you know, do this profiling of your application as you deploy it and then build a native image based on that. But again, you always want to make sure that you want to be sure that your native image works first. I mean, that's the most important thing, right? That you know what the Java application that you're building is something that can be turned into a native image. Frameworks and things that are production ready, right? I would always suggest, if you're going to use native image, that you probably want to go with a framework, because the people building the framework that support it have done a lot of the hard work for you. They've straightened the path. They've made assumptions. They've fixed things that basically make native image easier to work with. I mean, Micronaut, for instance, works really well. Helidon SE, which is the sort of more functional version of the Helidon microservices framework, and Quarkus, all of these basically work with native image and let you generate native images. I think Micronaut certainly contains a bit of tooling that calls the tracing agent, that lets you capture stuff and generates certain information as well based on your application to tell the native image tool about some of the reflection, etc., that might happen. Native class loading. Spring. So Spring is in the process of working with the GraalVM Oracle Labs team to bring Spring Boot native image, make Spring Boot native image friendly, basically, to let it build these executables. And I've got a little bit of information about this. It's still work in progress, but Spring Graal Native 0.6.0, that's supposed to say, not 0.6.0. That's just been released in April, and this is a Spring feature that's been worked on to make working with Spring Boot and GraalVM easy. It's work in progress, but you can go and follow its progress online. If you search for Spring Projects Experimental and GraalVM Native, you can find out the current state of play. I think, as I read it, I mean, obviously I don't work for Pivotal, so this is just what I've read. The Spring, the GraalVM Spring Native framework can make a lot of Spring Boot applications work, but you may need to do a bit of work to work around the edges. It's not entirely seamless at the moment, but they're working hard to make sure that you will be able to take your Spring Boot application, and make a native image out of it at some point soon. And there's the blog post, which is quite interesting, relating to this, worth reading if you want to find out what the current state of play is with that, because I guess most people are using Spring for their framework. I talked a bit about securing untrusted code. This is outside of the 3 pillars, basically, but there's a number of security aspects to GraalVM. If you can imagine you're embedding one language inside of another, say you're embedding JavaScript into Java, and you might want to do that so that you can add a scripting language to your application. So Oracle do this, Oracle NetSuite do this. They created a JavaScript-based scripting language so customers could configure their domain, their application. And they use GraalVM to provide this polyglot functionality. So when a user uploads their JavaScript file, it can't just do everything. They want it sandboxed in some way. So GraalVM's polyglot functionality, when you create a polyglot context inside of Java, there are ways to sandbox it. You can switch off access to the certain parts of the host OS. You can switch off access to threads, to the file system. You can sandbox it by the number of operations it's allowed to do before it dies, etc. If you look on the documentation, there's quite a lot around this, but there are ways that you can secure embedding one language inside of another. Another aspect of security is the LLVM managed runtimes, the managed execution. As I said earlier, if you compile your C or C++ with Clang and produce LLVM bitcode, like emit LLVM, if you look at the little code snippet down below, this can be loaded by Graal, and the memory can be managed by the GraalVM. The arrays that are called inside, arrays that are used inside the C or C++ program can be checked so that you're not overshooting array bounds. And there are various other checks. You trade performance for that, but you gain safety, like a whole kind of class of, typical native execution kind of problems can be resolved by running them on top of the Enterprise Edition of GraalVM. WebLogic, it's certified I talked a bit about this. If you have WebLogic 12x or 14, that's now certified to run on top of GraalVM 19.3, like the long-term support version. And you should see a performance increase. And basically, there's 0 code changes. Graal, I keep saying this, but Graal is a compliant JVM, right? So if you can have an application that works on your current JVM, whatever that is, you can use GraalVM and it will just work. I mean, that's interesting if you use your WebLogic. I don't know how many of you do. Some large organizations have a lot of it. The PolyGlot functionality, it's available. It obviously would work, but I don't think it's supported yet. But I mean, if you wanted to start using some more interesting things, but you use a lot of WebLogic server, might be a way to experiment with it. The PolyGlot functionality would be available and give you maybe some interesting new ways to play with things. So I'm now going to try and show you a little bit of the PolyGlot functionality. So I've talked an awful lot, probably far too much for myself and for you to listen to. So I've got a couple of demos here of the PolyGlot functionality. Let me just try and move the bar out of the way. So I've got a little demo here that basically is a tiny little Express app that shows a number of integration features with the JVM and with the other hosted languages. So here we can see that we're loading like a Java type, big integer, and that's just available now inside my Node JavaScript application. And I can call it. I can call methods of it, Java methods basically. I can take the number 10, raise it to the power 100, and then add, 43, whatever it is, and get back a string. Big, large number support in Node, I don't think is great. I don't know a great deal about Node, not a huge amount anyways, but some things the JVM does really well. For instance, the math support. So great that you can use that inside of other programming languages. And now we've also got a bit of interference. Now we've also got the ability to call other hosted languages inside one hosted language. So this is JavaScript, right? And here we can see evaluating a little snippet of R code. I don't speak R, but I'm sure this is doing something very clever. I guess it's saying if 1 is greater than 2, which is false, then do this. So again, we're able to call R, and then we've got perhaps a bit more of a kind of clever little snippet here. This loads the SVG module. So whatever happens inside the SVG and the SVG off will generate SVG instead of going to some kind of plot device. And we take X being a number between 1 and 100, and then Y being the sign of X divided by 10, and Z being something else clever. And we generate a graph from that. Again, what that returns is SVG text. And then we send that back to the user. So if we have a look at running this application, we should see, this one. So if I run this application, I'm running Node, right? And then just kill, but just to show you which node, this is the node that is bundled inside of the GraalVM distribution, right? So if I run it, I have to pass some flags to tell it that it's polyglot. I'm using lots of different languages. And if I go to where's the browser gone? If I go to port 3000, I don't know, can you still see my browser? Somebody give me a thumbs up. Yeah.
Yeah.
Perfect, thank you. The application takes a little time to run because it's doing some chunky processing. Oh, I've got impatient, sorry. So we can see we've got a JavaScript string up there. Then we've got this huge number that we generated with big integer from Java. Then we had a little bit of R that we evaluated. And then we plotted we used R to plot some, clever mathematical functions and get a nice SVG plot out of it, which I think is really interesting. So when I showed you that graph earlier on of like the different programming languages all sat on top of the same runtime, this is the kind of thing that I'm imagining, that we use like a language that makes sense for a particular job. In some languages, it's far more concise to express a problem than it is in others. If you've got some kind of data science or maths type thing, R or Python maybe is the best, the best solution. You don't want to necessarily, it's easy to understand and reason about, probably maybe write in a different language, right? So it gives you options and allows you to build your applications in new ways. So I kind of like this because it's, quite showy, and that it generates an SVG plot using R. But it kind of shows like some of the potential, for what could be done. And then the second, if I kill that, yeah, and then I think it's, yeah, PolyGlot 2. So the second application I was going to show you is basically how we could call some Java, kind of a fancy Java library from some JavaScript. So I not my own code. I'd taken this from the TensorFlow, how to get Java TensorFlow, how to get started site, and it's an image classifier. So it loads a pre-trained model, loads the native JNI type things that are needed by TensorFlow that do like the heavy lifting, and produces a classification. If we try and run this, I think it's run, and then I need to. So I've got a little. I've got a little script that basically runs it. All this does is calls my Java application with the TensorFlow library and my classes directory that I've pre-compiled, some JNI stuff, and then my label image class, and then you just have to pass in the image file that you want to classify. So let's try this. This is bound not to work, so apologies in advance. Images, I don't know, mouse. So I'm going to see if it will classify a mouse for me. Oh, it says it's a mink, so not too bad. But you can see that it's actually working. So that would seem pretty cool, and maybe a bit of functionality that I'd like to use elsewhere. So if I go and then take a look inside my next, so then I built an Express app, basically, that's an image gallery. And if I run that application, let's just show you what's inside the script that starts it. Basically, fairly standard kind of stuff. It passes in a script that runs the application. The application is an image gallery. I'll show you the application first, so you can get a feel for it, and then I'll try and explain the changes I need to make to bring that Java library into it. So let's just have a look at it first. Okay, so we've got some images, and all of them have a title, a thing, right? So if I look at the code for this, it's inside a controller that generates this page, basically that's responsible for generating this page. What do? We read the directory, which happens to be the directory with the images in. Yeah. We build up a path. We then just push these images with their title, which at the moment is just set to a thing. And then a layout file renders this for us, a view and a layout file renders this for us, basically. So at the moment, it's not really doing anything. But if we look to start bringing in the Java library that I showed you earlier. So if I uncomment a few lines, and I'll just talk through them. That Java class I showed you that did the image classification earlier, I can now add that to my my JavaScript application. So there's this, I mentioned it before, this Java object now, where I can create a Java type that's on the class path. And I don't know if you saw, I'll show you the run script I started the application with earlier. But basically, you can see that when I call node, I pass in some class paths and all of the kinds of parameters that you can pass to the JVM. So that kind of knowledge is now available to Node. It knows what's on the class path. It knows about JNI stuff if I choose to add any. So now I've got this classifier, Java classifier object inside my JavaScript application. I can call methods on it. For instance, I've get an object back from this, which is my actual classifier based on loading a model, which is somewhere on my file system, right? The model is the TensorFlow train model. And then down here, instead of just setting my class variable, which holds the classification of something to just a string, a thing, I can call my classifier object with the path, with the JavaScript path to the image in the application. And I can let my classifier try to classify that and give me back a string that JavaScript understands, and then pass that over back to the rest of my JS. So I think I've changed all the things in this file to make it use the classifier. And then if I go back and kill that, and we'll have a quick look at the run script again. If you can see at the bottom, I don't know how well you can make this out. I can maybe make the font a bit bigger if it's not super visible. I'm calling node, I'm passing in, I'm telling it I'm using the JVM and it's PolyGlot. I'm passing in a class path, so I can tell it about classes in the same way that I could when I called my Java application earlier on. Java, I told it about what jars I needed and where my application class paths were. I can pass in other parameters to the JVM, yeah, so like the library path, and they're all now available in my application. So let's run it. This is bound not to work, but here goes. So this is going to be really slow, because if this has worked, it's not the most well-written application. It does all the classification up front. So you can imagine for each of the images in the gallery, it performs a classification. It loads all those up into a structure that's then used for rendering the view. So it's slow, unfortunately. But give it a second. I'm hoping we will now have some kind of classification. Great. So we've got a giant panda here. This classification up here is coming from the Java library we wrote, right? So we didn't need to write anything. We could take an off-the-shelf Java library and use it in our node to bring in a bit of kind of funky functionality. I don't know, we'll have a look at some other things. It's got very confused there. Grey whale, 100% off on that. But in its defense, it did say it was 28% likely. Yeah, that's not bad. That's pretty good. Mink, it's a very scary looking mink. Lion's good. I can see why it thinks that it's a dam. Again, not hay, but I can see why. Baboon is pretty good. Cauliflower, maybe, maybe not. Pinwheel, no. Yeah, that's pretty good. Cat. I like that it can tell the difference between cats. That's obviously clearly way off. Yeah, monarch butterfly. No, that's oh, that's not a mink. What is it? That's a wolverine, right? Again, way off. 80s magician, whose name is really eludes me at the moment and bugs me every time I do this, present this, but I'm sure somebody out there will remember him. David Copperfield, maybe? But you get the idea. Now we've got this ability to, bring in different libraries and bring them together in like a single application, which kind of gives us maybe some new ways of thinking about how we build applications. Maybe in some cases things could be simpler, right? They could all just be in the same application, same address space, talking to each other without any networky stuff in between. One thing to be aware of, 20.1 is released today, and can't say anything too much about what's in it until it's actually formally released, but there should be some performance improvements and some improvements to native image. So you probably want to check that out today. The version roadmap, well, we have this release cycle now. It's a proper product. Even like the community edition is being released on a very similar schedule. So every 3 months, there's this predictable release of a new version. I've got a, yeah, this is maybe easier to understand. it shows the versions, the major patches up above, and the first part of the number, say like 20, is the year 2020. 21 is 2021, and off each patch, each major version, sorry, we get a patch version with any fixes relating to that particular release. And there is also a long-term support version. So, you know, if you commit to using, say, 19.3, you know that that's maintained, and patches are going to be applied to that for, you know, a number of releases. There's lots of ways to keep track of the project. You can follow us on Twitter. Obviously, there's a Slack channel, GraalVM. Please do go and check out the project on GitHub. The Graal library has, you know, huge amounts in it. There's a mailing list as well. So we're always interested in people following the project and finding out more about it and, you know, giving us feedback. Definitely want, you know, feedback on it. Get started. You know, please do go and download GraalVM. Try out either the Community Edition or the Enterprise Edition. I think for the Enterprise Edition, like I said, it's OTN license. You need to create an Oracle OTN like login, but that's just a case of accepting the license terms, and then you can use it for development, whatever. Or the Graal Community Edition is available as well. That's also, you know, great. There's lots of community support, and the website has got tons and tons of really useful information about how to get started with Graal, what its features are, what you can do with it, and it's a really good place to get started. Oh yeah, and don't forget GraalVM demos, the GitHub repository I mentioned before, all that blog post, top 10 things. There's quite a lot if you start searching the web for useful resources on getting started. But the big thing, if anything, I'd like you to come away from this is it can seem confusing in what it does, like any new technology. Really just think about, you know, de la Soul, 3 things, you know. There's a new JIT compiler that hopefully offers more performance for Community Edition, definitely for Enterprise Edition. There's going to be better for modern, you know, abstract applications, Java applications. It's polyglot functionality, and this this native image functionality that's all about generating fast startup times, low package size, low memory, executables, native executables for using containers like in microservices and function as a service, anywhere where the application isn't going to run for a very long time. So you don't want to be paying the warm-up penalty of the JVM repeatedly. And thank you very much. My wingman, Simon, has been, wow, 99 things in the chat box. I'd like to have a go at answering some questions. I don't know what the best way to do this is. Simon, over to you. What do you think?
I'm not sure what to suggest, Kris, because
let's have a look from the top. Yeah, let me have a look.
There have been quite a lot of answers that have been coming into the questions.
Why is it named GraalVM? That's a great question. Graal is kind of German, I think, for the Grail, you know, the Holy Grail. So it's the thing that everyone's been searching for. I think that was the idea behind it. So that's why it's called GraalVM, and it's a virtual machine. So that's the first question. Okay, and someone's put, yeah. How does garbage collection is working on GraalVM compared to Hotspot? If you use it in JIT mode, you can use the same garbage collectors. You can switch in the same way as you do. If native image, it's not in the Community Edition. There's the kind of default garbage collector. In the Enterprise Edition, we have like G1, which is much better performant. So it depends. You know, if you're using it in Java and JIT mode, much the same. If you use it native image, you know, the different versions have different GC. Unlock experimental features. Yeah. Sorry, I wasn't answering these as we go. I wasn't ignoring you. I just find it impossible to read and talk at the same time. Limitation of my brain. I'm not multi-threaded. Yeah, okay. Good question. Is it possible to create a native image for a language different than Java? At the moment, JVM languages, you can create native images from them. You can have them run the hosted languages like JavaScript. at the moment, there you can't just take a JavaScript application and make a native image out of it, though that may change. That's kind of like work in progress or research work at the moment. And if you think about it, obviously JavaScript is like inherently dynamic. A lot of these hosted languages are. So at the moment, JVM ones that you can embed the hosted languages in, but the hosted languages won't be native compiled. There's a section, if you look on the GraalVM.org website, that talks about this. So that would be a good place to look for that. You already have a look at this post. Okay. I know. Is there any equivalent to instrumentation? If you're running it in JIT mode, Java mode, then yeah, you can use Flight Recorder. We've got the Visual VM. If you're using native image, we can generate in the Enterprise Edition. We can generate heap dumps, which you can use to look at your application to find out some information about it. But at the moment, there isn't any instrumentation for native image. Okay, yeah, nice resource, awesome Graal. Thank you, Manny. Aspect-oriented frameworks, yeah, okay. Can they work in ahead of time mode? I guess your mileage will vary. One of the things that Micronaut does is they do their kind of, they use these annotations that run, what's the correct term, but they basically run before the application is run, like at build time. So things like that you can do some quite clever things with. I guess it would depend on the framework. I would probably need to dig into that one, I'm afraid. Aspect J, etc. Someone's saying will still work. Native image, possibly. I don't know. I've never tried it. I would want to have a look at that. Maybe that's something I can have a look at and we can do a blog post about. Okay. Yeah, reflection, it does, obviously, and we talked about this. Basically, any kind of reflection, it kind of violates the closed world assumption in some sense, and we need to tell native image about it. But that's not like a complete game killer, game stopper. We can use the tracing agent, or we could use like eyeballing and generate these files ourselves to work around this. So there are options, and you might think that that was really limiting, but there's a long way you can get with doing that a native image. Yeah, great answer, Gary. Okay, Spring AOP, yeah. Some Spring stuff does work. You would want to go and check out the websites I linked to earlier for exactly what does work and doesn't work. You need to work around certain features. I think they're at a point now where the GraalVM feature for Spring can do a lot of things and can solve a lot of the problems, but there will still be work involved. Yeah, and Graal may speed up your runtime even without AOT. Okay, reflection orientation again. Let's have a look at this. So if I use the community edition of Graal with Java's module support and create a deployment package that consists of my code and subset of JDK, can I freely... Okay, licensing. I do love licensing. Yeah, if you want to, basically, I think if you're distributing something that is derivative in some sense, then something derivative that contains a GPL style license, then everything becomes available under open source. Obviously in CE, everything is open source. With the Enterprise Edition, that might be different, that would affect how you would distribute it, but I think you'd need to have a conversation on a case-by-case basis, basically. I wouldn't want to give any kind of opinion on that right now. Okay. GraalVM and ZGC or Shenandoah, not at the moment that I'm aware of. I think that's probably a topic of research at the moment. Yeah, there's a blog post on, if you go on the GraalVM org website, about Rhino, Nashorn, sorry, and migrating to using GraalVM and Node. That goes into probably more depth than I can here, but I would suggest, I think that's on the homepage. If you scroll down a little way, there's a good in-depth article on that particular topic, migration from Nashorn to Node using GraalVM. And yes, it's a valid way to migrate your code. Okay. GraalVM JavaScript will compare in performance to Nashorn. I'm not sure. I'd have to try and dig out some statistics or some actual benchmarks for that. But I would expect it the GraalVM performance, once it's warmed up, to be very good, because obviously you've got the GraalVM compiler in there, and also the truffle implementation layer has got like certain optimizations in it. Yeah, that's probably something, if you're welcome to contact me, like on email. I'll share my email afterwards with specific questions and I'll try and answer them. That's one. If you contact me, was it Yuri? Yeah, I'll try and get you some information on that. Yeah, someone else has said it underneath. I would suspect it is, but I'm always reticent without actual figures. Simple. Okay. Yeah. Okay. Okay. Yeah. There's more. Yeah, so support in terms of platforms, obviously Linux, macOS, and Windows support is now available for Java, the JIT mode, and also for native image. Arch64, I think is, or at least is experimental. So that is an option. I don't think we're going to support 32. Okay, that's an internal question. Okay. My eyes are starting to hurt. My throat's also starting to hurt. Maybe, has anyone got any questions that you want to ask me, right? Maybe we could sort of take one at a time. In fact, just ask it out loud rather than typing in the chat box might be easier. No? Gary? Is that Gary Frost? Were you about to ask a question?
Can you hear me?
Yeah. Hi, how you doing?
Hey, how you doing? I was wondering, I had two questions really. One you kind of skipped over earlier. I asked the question, currently Graal is available in the OpenJDK. You don't have to use the GraalVM.
Yeah.
But you have to put up flags in front of it to turn it on.
Yeah.
It can replace C2 and it's very good. But the problem is some customers that I work with will not let us touch their command line. And
right.
So we're unable to show them the advantage of Graal. I think it's the same problem. It's the same problem actually GraalVM is going to have, that some places will forbid you from touching their command line because it's worked for them for many years and they don't want you to mess with it. So I was wondering if we know when Graal itself might just replace C2 without us having to request it as an experimental option.
Yeah, that's an interesting question actually, and I have in my previous incarnations worked at places where I had to sit next to somebody and tell them what to type. And that was a god-awful experience, because it's weird, isn't it, when you sort of instinctively think as you type, and typing and dictating to somebody what you want to type in terms of like alternate command line, hellish experience. At the moment, I don't think there's any plans. I don't know it's clear yet what the future in terms of like merging them will be. They're two different kind of products, really, in a way, projects. And that kind of makes sense to me, at least in a lot of ways, because there's a lot of people who have been using Java and say maybe OpenJDK or Oracle Hotspot for a long time, and they don't want to change. allergic to changing and any kind of like release. There's so many people on like Java 1.8 still, right? And so it makes sense to have like that separate product line, because there are people who just want that. The GraalVM is maybe it contains some novel new features. Not everyone's going to be comfortable with that, and it makes sense to keep them separate for now. In the future, who knows whether the two will come together? I don't know really, basically. But for now, that it makes sense to think of them as separate, separate projects. And in a situation like that, I think it might be very difficult to convince a customer if they won't let you do that. They're probably hugely risk averse, right?
No, not really. It isn't. It's just that you put the word experimental in the option. Instead
right.
of latest version or upgrade, and you'll be fine. I'm thinking. I used to work at Google and I worked at Facebook, and neither of those would let you turn these on, because of the nature of the options.
That's an interesting take, actually. Yeah.
And what's really weird is, I mean, we've turned it on. I was at Facebook. We did ahead of time. We actually bought Thalwinger. Is that his name?
Kris Salinger.
Yeah, we brought him in, and it was great. Yeah. But everyone said, until this is mainstream, until Graal itself can compile without you putting special flags on the command line. So we just imagined that after 5 iterations, this would go away and it would be used without us having to express. The same way that garbage collection comes in as experimental and then G1 becomes the norm, etc. Anyway, it's just a comment, because a lot of the things that Graal enables folks to do, I mean, I've been using it since 2014. But you can't, I don't know whether you remember Sumatra, but that was one of the first uses, trying to get GPU offload through Graal. And our problems all along has always been many companies won't let you play with their command line. So if Graal just came in and started using, if the JVM just came in and started using Graal without any intervention, people would be very happy, I think, with performance. It's the fact that you have to put the word experimental on the command line.
That's interesting feedback. I'll definitely pass that along. That's that's an interesting take. Thank you for that. Anyone else got a question? We're probably going to have to wrap it up soon, because I don't know if I can talk anymore. It's been a while. No, we all good? Oh, fantastic. First off, again, thank you to RetWorks, Dom and Barry for organising this. I really appreciate it. And thank you for everyone who came and listened to me go on and on and on and on from sunny Swindon with the palm trees in the background. Really appreciate you taking the time to find out about Graal. I don't know if I can share my email address. Maybe I can. If you've got any questions, always really happy, or suggestions. I think one of the things we're really keen for, and one of the things I really like, right, is working with customers who are doing POCs, because they suggest things that we may never have thought of, use cases or things that are important. And so we're definitely at the stage of really enjoying hearing feedback. Who knows, that may change, but please do feel free to get in touch. Or maybe if I put my work email address in the chat box. Oh, God, my eyes. It gets to this point of the night where I can barely see. Feel free to Tornado VM. I would, yeah. Feel free to send me emails asking about Graal. Please, no spam, no offers for, I don't know, cut price shoes or secondhand televisions, whatever. But thank you again, everyone. Really appreciate your time. Thanks a lot.